Introduction to Polymer Chemistry. Exercise pages 337 to 339. Exercise Q1.01, page 337. Choose the correct option from the given alternatives. Nylon fibers are underscore 1. Semi-synthetic fibers. 2. Polyamide fibers. 3. Polyester fibers. 4. Cellulose fibers. Solution. Nylon fibers or polyamide fibers. Exercise Q1.02, page 337. Choose the correct option from the given alternatives. Which of the following is naturally occurring polymer? 1. Teflon. 2. Polyethylene. 3. PVC. 4. Protein. Solution. Protein. Exercise Q1.03, page 337. Choose the correct option from the given alternatives. Silk is a kind of underscore fiber. 1. Semi-synthetic. 2. Synthetic. 3. Animal. 4. Vegetable. Solution. Silk is a kind of animal fiber. Exercise Q1.04, page 337. Choose the correct option from the given alternatives. Dacron is another name of underscore. 1. Nylon 6. 2. Orlan. 3. Novalac. 4. Terylene. Solution. Dacron is another name of terylene. Exercise Q1.05, page 337. Choose the correct option from the given alternatives. Which of the following is made up of polyamides? 1. Dacron. 2. Rayon. 3. Nylon. 4. Jute. Solution. Nylon. Exercise Q1.06, page 337. Choose the correct option from the given alternatives. The number of carbon atoms present in the ring of caprolactam is 1. 5. 2. 2. 3. 7. 4. 6. Solution. 6. Exercise Q1.07, page 337. Choose the correct option from the given alternatives. Terylene is underscore 1. Polyamide fiber. 2. Polyester fiber. 3. Vegetable fiber. 4. Protein fiber. Solution. Terylene is polyester fiber. Exercise Q1.08, page 337. Choose the correct option from the given alternatives. PET is formed by underscore 1. Addition. 2. Condensation. 3. Alkylation. 4. Hydration. Solution. PET is formed by condensation. Exercise Q1.09, page 337. Choose the correct option from the given alternatives. Chemically pure cotton is underscore 1. Acetate rayon. 2. Viscose rayon. 3. Cellulose nitrate. 4. Cellulose. Solution. Chemically pure cotton is cellulose. Exercise Q1.1, page 337. Choose the correct option from the given alternatives. Teflon is chemically inert, due to presence of underscore 1. CH bond. 2. CF bond. 3. H bond. 4. C equals C bond. Solution. Teflon is chemically inert, due to presence of CF bond. Exercise Q2.1, page 337. Answer the following in one sentence. Identify A and B in the following reaction underscore. Solution. Polymer A is. Exercise Q2.1, page 337. Answer the following in one sentence. Identify A and B in the following reaction underscore. Solution. Exercise Q2.2, page 337. Complete the following statement. Caprolactam is used to prepare underscore. Solution. Caprolactam is used to prepare nylon 6. Exercise Q2.2, page 337. Complete the following statement. Novalac is a copolymer of underscore and underscore. Solution. Novalac is a copolymer of phenol and formaldehyde. Exercise Q2.2, page 337. Complete the following statement. Pterylene is polymer of terephthalic acid and ethylene glycol. Solution. Pterylene is condensation polymer of terephthalic acid and ethylene glycol. Exercise Q2.2, page 337. Complete the following statement. Benzoyl peroxide used in addition polymerization acts as _. Solution. Benzoyl peroxide used in addition polymerization acts as initiator. Exercise Q2.2, page 337. Complete the following statement. Polythene consists of polymerized _. Solution. Polythene consists of polymerized ethene. Exercise Q2.3, page 338. Draw the flowchart diagram to show the classification of polymers based on the type of polymerization. Solution. Exercise Q2.4, page 338. Answer the following in one sentence. Write examples of addition polymers and condensation polymers. Solution. 1. Addition polymers. Polythene, Teflon, polyacrylonitrile, polyvinyl chloride, PVC, etc. 2. Condensation polymers. Pterylene, NYLON6, bakelite, Novolac, etc. Exercise Q2.5, page 338. Answer the following in one sentence. Name some chain growth polymers. Solution. Chain growth polymers are polyacrylonitrile, polyvinyl chloride, polythene, etc. Exercise Q2.6, page 338. Answer the following in one sentence. Define the term monomer. Solution. Small molecules that are interlinked together to form polymers are called as monomers. Exercise Q2.6, page 338. Answer the following in one sentence. Define the term vulcanization. Solution. The process by which a network of crosslinks is introduced into an elastomer is called vulcanization. Exercise Q2.6, page 338. Answer the following in one sentence. Define the term synthetic fibers. Solution. Man-made polymeric solids which form threads are called synthetic fibers. Exercise Q2.7, page 338. Answer the following in one sentence. What type of intermolecular force leads to high-density polythene? Solution. Van der Waals forces between closely packed linear polymeric chains are responsible for high-density polythene. Exercise Q2.8, page 338. Answer the following in one sentence. Give one example each of copolymer and homopolymer. Solution. 1. Copolymer. Buna S. 2. Homopolymer. Polythene. Exercise Q2.9, page 338. Answer the following in one sentence. Identify thermoplastic and thermosetting plastic from the following. 1. PET. 2. Urea formaldehyde resin. 3. Polythene. 4. Phenol formaldehyde resin. Solution. 1. Thermoplastic. Polythene, PET. 2. Thermosetting plastic. Urea formaldehyde resin, phenol formaldehyde resin. Exercise Q3.01, page 338. Answer the following. Write the names of classes of polymers formed according to intermolecular forces and describe briefly their structural characteristics. Solution. 1. Polymers are classified into various categories on the basis of intermolecular forces as follows. Elastomers. Fibers. Thermoplastic polymers. Thermosetting polymers. 2. Their structural characteristics are as follows. I. Elastomers. Elastomers have the property of elasticity in which a substance gets stretched by external force and restores its original shape on the release of that force. Elastomers, the elastic polymers, have weak van der Waals type of intermolecular forces that permit the polymer to be stretched. A few crosslinks between the chains help the stretched polymer to retract to its original position on removal of applied force. E.g., vulcanized rubber, Buna S, Buna N, neoprene, etc. E. Fibers. Polymeric solids which form threads are called fibers. The fibers possess high tensile strength, which is a property to have resistance to breaking under tension. High tensile strength is due to the strong intermolecular forces like hydrogen bonding and strong dipole-dipole forces. Due to these strong intermolecular forces, the fibers are crystalline in nature. E.g., polyamides, nylon 6, 6 polyesters, terylene, etc. E. Thermoplastic polymers. Thermoplastic polymers have the property of plasticity, that is, these polymers can be easily shaped or molded. They are capable of repeated softening on heating and hardening on cooling. These polymers possess moderately strong intermolecular forces that are intermediate between elastomers and fibers. E.g., polyethylene, polystyrene, polyvinyls, etc. IV. Thermosetting polymers. Thermosetting polymers are rigid polymers. During their formation, they have the property of being shaped on heating, but they get hardened while hot. Once hardened, they cannot be softened by heating and therefore cannot be remolded. This characteristic is the result of extensive cross-linking by covalent bonds formed in the molds during hardening, setting process while hot. E.g., bakelite, urea formaldehyde resin, etc. Exercise Q 3.02, page 338. Answer the following. Write the reaction of the formation of nylon 6. Solution. Exercise Q 3.02, page 338. Answer the following. Write the reaction of the formation of terylene. Solution. Exercise Q 3.03, page 338. Answer the following. Write structure of natural rubber and neoprene rubber along with the name and structure of their monomers. Solution. Exercise Q 3.04, page 338. Answer the following. Name the polymer type in which following linkage is present. Solution. The polymer containing ester linkage is called polyester. Exercise Q 3.05, page 338. Answer the following. Write structural formula of the following synthetic rubbers. SBR rub. Solution. Exercise Q 3.05, page 338. Answer the following. Write structural formula of the following synthetic rubbers. Buna N rubber. Solution. Exercise Q 3.05, page 338. Answer the following. Write structural formula of the following synthetic rubbers. Neoprene rubber. Solution. Exercise Q 3.06, page 338. Answer the following. Match the following pairs. Name of polymer. Monomer. 1. Teflon. A. CH2 equals CH2. 2. PVC. B. CF2 equals CF2. 3. Polyester. C. CH2 equals CHCl. 4. Polythene. D. C6H5OH and HCHO. 5. Bakelite. E. Dicarboxylic acid and polyglycoxyglycol. Solution. Name of polymer. Monomer. 1. Teflon. B. CF2 equals CF2. 2. PVC. C. CH2 equals CHCl. 3. Polyester. E. Dicarboxylic acid and polyglycoxyglycol. 4. Polythene. A. CH2 equals CH2. 5. Bakelite. D. C6H5OH and HCHO. Exercise Q 3.07, page 338. Answer the following. Draw the structures of polymers formed from the following monomers. NHOOCr2 plus NHORO. Solution. Exercise Q 3.07, page 338. Answer the following. Draw the structures of polymers formed from the following monomers. H2N, CH2, 5COOH. Solution. NHCH2, 5 Colorado N. Exercise Q 3.08, page 338. Answer the following. Name and draw structure of the repeating unit in natural rubber. Solution. Repeating unit in natural rubber is obtained from the monomer isoprene. Structure of repeating unit is. Exercise Q 3.09, page 338. Answer the following. Classify the following polymers as natural and synthetic polymers. A. Cellulose. B. Polystyrene. C. Terylene. D. Starch. E. Protein. F. Silicones. G. Orland polyacrylonitrile. H. Phenolformaldehyde resins. Solution. Polymer. Type of polymer. A. Cellulose. Natural. B. Polystyrene. Synthetic. C. Terylene. Synthetic. D. Starch. Natural. E. Protein. Natural. F. Silicones. Synthetic. G. Orland polyacrylonitrile. Synthetic. H. Phenolformaldehyde resins. Synthetic. Exercise Q 3.1, page 338. Answer the following. What are synthetic resins? Name some natural and synthetic resins. Solution. Synthetic resins. These polymers are artificially prepared by polymerization of one monomer or copolymerization of two or more monomers, e.g. nylon and terylene. Synthetic polymers are further divided into three subtypes: fibers, synthetic rubbers, and plastics. Natural resins. Natural rubber, silk, wool, etc. Synthetic resins. Nylon, terylene, neoprene, etc. Exercise Q 3.11, page 338. Answer the following. Distinguish between thermosetting and thermoplastic resins. Write example of both the classes. Solution. Thermosetting resin. Thermoplastic resin. They do not soften on heating. They soften on heating and harden on cooling. They cannot be remolded or reshaped. These can be remolded or reshaped. They possess extensive cross-linking formed by covalent bonds. They possess moderately strong intermolecular forces that are intermediate between elastomers and fibers. They are rigid polymers. They are not rigid polymers, e.g. bakelite, urea formaldehyde resins, etc. e.g. PVC, polythene, polystyrene, etc. Exercise Q 3.12, page 338. Answer the following. Write name and formula of raw material from which bakelite is made. Solution. Bakelite is made by condensation of two different monomers. A. Phenol. B. Formaldehyde. CH2O. Exercise Q 4.1, page 338. Identify condensation polymers and addition polymers from the following. Solution. It is an addition polymer. Exercise Q 4.1, page 338. Identify condensation polymers and addition polymers from the following. CH2CH equals CH, CH2N. Solution. It is an addition polymer. Exercise Q 4.1, page 338. Identify condensation polymers and addition polymers from the following. CO, CH2, 4CONH, CH2, 6NHN. Solution. It is a condensation polymer. Exercise Q 4.1, page 338. Identify condensation polymers and addition polymers from the following. Solution. It is a condensation polymer. Exercise Q 4.2, page 339. Attempt the following. Write the chemical reactions involved in the manufacture of nylon 6,6. Solution. Exercise Q 4.3, page 339. Attempt the following. Explain the vulcanization of rubber. Which vulcanizing agents are used for the following synthetic rubber? A. Neoprene. B. Buna N. Solution. A. Neoprene. MgO is used to vulcanize neoprene. B. Buna N. Sulfur is used to vulcanize Buna N. Exercise Q 4.4, page 339. Write chemical reaction to prepare the following polymer, Teflon. Solution. Exercise Q 4.4, page 339. Write the reaction involved in the formation of bakelite. Solution. Step 1. Step 2. Step 3. Exercise Q 4.5, page 339. Attempt the following. What is meant by LDP and HDP? Mention the basic difference between the same with suitable examples. Solution. 1. What is meant by LDP and HDP? Mention the basic difference between the same with suitable examples. 2. LDP is a branched polymer of ethene with polymeric chains loosely held. Hence, even though it is tough, it is extremely flexible. Therefore, LDP is used in producing extruded films, sheets, mainly for packaging and household uses like in preparation of squeeze bottles, attractive containers, etc., where low tensile strength and flexibility is required. On the other hand, HDP is a linear polymer of ethene with closely packed polymeric chains. Hence, it is much stiffer than LDP and has high tensile strength and hardness. Therefore, HDP is used in the manufacture of toys and other household articles like buckets, dustbins, bottles, pipes, laboratory wares and other objects where high tensile strength and stiffness is required. Exercise Q 4.6, page 339. Attempt the following. Write preparation, properties and uses of Teflon. Solution. Preparation of Teflon. 1. The monomer used in preparation of Teflon is tetrafluoroethylene, CF2 equals CF2, which is a gas at room temperature. 2. Tetrafluoroethylene is polymerized by using free radical initiators such as hydrogen peroxide or ammonium persulfate at high pressure to produce polytetrafluoroethylene Teflon. Properties of Teflon. 1. Teflon is tough, chemically inert and resistant to heat and attack by corrosive reagents. 2. F bond is very difficult to break and remains unaffected by corrosive alkali, organic solvents. Uses. Teflon is used in making nonstick cookware, oil seals, gaskets, etc. Exercise Q 4.7, page 339. Attempt the following. Classify the following polymer as straight chain, branched chain and cross-linked polymers. Solution. Straight chain polymer. Exercise Q 4.7, page 339. Attempt the following. Classify the following polymer as straight chain, branched chain and cross-linked polymers. Solution. Branched chain polymer. Exercise Q 4.7, page 339. Attempt the following. Classify the following polymer as straight chain, branched chain and cross-linked polymers. Solution. Cross-linked polymer. Exercise Q 5.1, page 339. Answer the following. How is polythene manufactured? Give their properties and uses. Solution. I. LDP is prepared by polymerization of ethylene under high pressure, 1000–2000 atm. And temperature 350 to 570 K, in presence of traces of O2 or peroxide as initiator. E. The mechanism of this reaction involves free radical addition and H-atom abstraction. The latter results in branching. E. Polymeric chains are loosely held due to branching and the polymer has low density. IV. Properties of low-density polyethylene. A. LDP films are extremely flexible but tough, chemically inert, and moisture-resistant. B. It is a poor conductor of electricity with a melting point 110 degrees Celsius. B. Uses of low-density polyethylene. A. It is mainly used in the preparation of pipes for agriculture, irrigation, domestic water line connections as well as insulation to electric cables. B. It is also used in submarine cable insulation. C. It is used in producing extruded films, sheets, mainly for packaging and household uses like in preparation of squeeze bottles, attractive containers, etc. B. HDP is a linear polymer with high density due to close packing. B. It is obtained by polymerization of ethene in presence of Ziegler-Natta catalyst, which is a combination of triethyl aluminium with titanium tetrachloride. B. Polymerization of ethene is carried out at a temperature of 333 K to 343 K and a pressure of 6 to 7 atm. X. Properties of high-density polyethylene. A. HDP is crystalline, melting point in the range of 144 to 150 degrees Celsius. B. It is much stiffer than LDP and has high tensile strength and hardness. C. It is more resistant to chemicals than LDP. X. Uses of high-density polyethylene. A. HDP is used in the manufacture of toys and other household articles like buckets, dustbins, bottles, pipes, etc. B. It is used to prepare laboratory wares and other objects where high tensile strength and stiffness is required. Exercise Q5.2, page 339. Answer the following. Is synthetic rubber better than natural rubber? If so, in what respect? Solution. Yes, synthetic rubber is superior to natural rubber. 1. Synthetic rubber has high mechanical strength. 2. It has high abrasion resistance. 3. It is resistant to petroleum, vegetable oils, light as well as heat. Exercise Q5.3, page 339. Answer the following. Write main specialities of Buna S, neoprene rubber. Solution. 1. Buna S. It has mechanical strength and has abrasion resistance. Hence, it is used in tire industry. 2. Neoprene. Neoprene is particularly resistant to petroleum, vegetable oils, light as well as heat. Hence, it is used in making hose pipes for the transport of gasoline and making gaskets. It is used for manufacturing insulator cable, jackets, belts for power transmission and conveying. Exercise Q5.4, page 339. Answer the following. Write the structure of isoprene and the polymer obtained from it. Solution. Exercise Q5.5, page 339. Answer the following. Explain in detail free radical mechanism involved during preparation of addition polymer. Solution. The free radical mechanism is most common in addition to polymerization. It is also called a chain reaction which involves 3 distinct steps. These are as follows. Step 1. Chain initiation. A. The chain reaction is initiated by a free radical which is formed from an initiator catalyst, such as benzoyl peroxide, acetyl peroxide, tert-butyl peroxide, etc. B. For example, acetyl peroxide generates methyl radical as shown below. C. The free radical, say R, so formed attaches itself to the olefin vinyl monomer, and produces a new radical, made up of 2 parts, namely, the attached radical and the monomer unit. E. Step 2. Chain propagation. A. The new radical formed in the initiation step reacts with another molecule of vinyl monomer, forming another still bigger sized radical, which in turn reacts with another monomer molecule. B. The repetition of this sequence takes place very rapidly. It is called chain propagation. C. This step is very rapid and leads to high molecular mass radical. E. Step 3. Chain termination. A. At some stage, termination of the growing chain takes place. It may occur by several processes. B. One mode of termination is by combination of 2 growing chain radicals.